Hi, today we'll be reviewing piecewise functions. Usually a function is defined by one formula, like f of x equals 3x plus 7, or g of x equals x squared, for every number. So take any x and square it, or take any x, multiply it by 3 and add 7, and that's for all of the x values. A piecewise function is just different formulas for different parts of the domain. So for different x values, you're going to use different formulas. For example, for x values less than 0, we'll use the formula negative x. So whatever x values are less than 0, we're going to put a negative in front of it, or make it the opposite. For values between 0 and 3, including 0 and 3, we'll square them. And for values greater than 3, we're going to have them equal 9 no matter what they are. So these three functions, here's the graph of negative x. We're only going to use that graph for the x values that are less than 0. So for these x values, these are greater than 0, we're not going to use the function negative x. So we're going to take that function and just put it for the values less than 0. This is the function x squared. We're only going to use the part between 0 and 3. So we're only going to use this part from here up to when x equals 3, which is going to be up here. So from here to here, including the ends. So none of this. We're not going to use any of this, and we're not going to use any of this. For this one, notice that x was not equal to 0, it was just less than 0. So we have to put a big hole there to show that we're not using that value at 0, 0. But this function has x equal to 0 at 0, 0. So that will have a solid filled in circle there, and at 3, 9, solid filled in circle there. How did I know that was 3, 9? Because 3 squared is 9. If you take any value between 0 and 3 and square it, that's what our rule says we're supposed to do. That's going to be this part of the graph. And then finally, we have the graph of 9, which is just a horizontal line at y equals 9. But that graph we're only going to use for x greater than 3. So we don't want any of these values here. We're only going to use that much of it. And again, we're not going to use the value at 3 because x greater than 3 means we don't use the value at 3. So we're going to have an open circle there. So open circle at 3, 9, and then all these values for x greater than 3. So what we need to do is put those three pieces together. And it's going to look something like this. When you want to graph this in the graphing calculator, you can. You go to your y equals, and then you have to use this notation. For the function, you put it in parentheses, and then nothing in between, and you just use parentheses to show which part of the graph is going to use that function. And then plus, and then the function in parentheses again. And then this is how you do the notation, like if we'd have 0 less than or equal to x less than or equal to 3. Oh, this isn't writing very well. Never mind. That's not going to let me erase it either. Okay. Oh, sorry. All right, so then that's the notation for values between 0 and 3, including 0 and 3. And then this is the function 1. Oh, that's supposed to be a 9. Sorry. For values greater than 1. And that's what your function looks like. Notice that open circle we had here got filled in by the x squared part, and this open circle we had here got filled in by the x squared part. Now if those two ends hadn't matched up, we would still have an open circle. Maybe this piece would have been up here with an open circle on it. And then this would have been a solid filled in circle. Just depends what the function is. So this, we would change this to negative x plus 3. So then that's what that piecewise function would look like. Negative x plus 3 is this piece for values less than 0, but not including 0, so open circle there. And there's the x squared between 0 and 3, including 0 and 3, and there's the graph of 9 for values greater than 3. A lot of typos here, sorry. Greater than 3. All right, so that's a piecewise function. Now, what's the purpose of piecewise functions? There are a lot of real-life examples for why we would use piecewise functions. Many things have different rates based on different input values. Cell phones used to have different rates based on the number of minutes you use, but most people just use unlimited minutes right now. So, or unlimited data plans or unlimited texting. But when cell phones first came out, if you were going to use between 0 and 1,000 minutes, then you were charged this rate, or over 1,000 minutes, you were charged a different rate. So that's kind of obsolete right now, but tax rates are very different based on how much money you make. For example, if you make between $0 and $8,375 a year, you're going to only be charged 10% for taxes. If you make over $373,500, you're going to be charged at a 35% tax rate. So all the tax rates are different based on how much money you make, so the different input values determine your tax rate. So that's a piecewise function, real-life piecewise function. Let's see if you know how to write a piecewise function based on a graph. So what you need to do is find the equation for the lines that are given there, and then just break it up in the domain. So you have to imagine that this graph goes on forever. Oh, that's bad. I didn't draw that very well. But imagine that graph goes on forever, and imagine this graph goes on forever. What would be the equation of this line? Well, this y-intercept is 0, and it looks like the slope is 1. So it looks like that part is y equals, these are just straight lines, so it's pretty easy, mx plus b. I don't know why that's doing that. Y equals mx plus b. Oh, it won't let me do that either. Oh, I see. Okay. I fixed it. Y equals mx plus b. I'll get rid of that. So the slope's 1 and the y-intercept is 0. So y equals 1x plus 0, or just x. So just for this part, we're going to have the graph y equals x. Which part of the domain is that for? Well, it starts at 0, including 0. So I know it's including 0 because it's a solid circle, not an open circle. And that goes all the way up to what x value? 1, 2, 3, 4. So the x value goes up to 4, but not a bar underneath it because we have an open circle, which means it doesn't actually equal that value. So we'll get rid of that. Okay, that's just for this part. Now let's look at this part. What's the equation of this line? Well, if we do extend it down here very carefully, what's that y-intercept? -4. So y equals mx plus b, we're going to have y equals m. Again, the slope is 1, up 1 over 1, up 1 over 1. So 1x, and then the y-intercept's -4. So that's the equation for that part of the graph. Which part of the graph is that? From 4 and up. So from values 4 less than or equal to x, or x greater than or equal to 4. So to put that all in a piecewise function, it's going to be this: x between 0 and 4, including 0, and x minus 4 from values from 4 equal to 4 and up, so values greater than 4. That's a review of piecewise functions.